Hi everyone, I'm Justin Weiss from IBM Research, and I'll be presenting this paper about human-AI partnerships in code translation. This is joint work with my colleagues at IBM, Michael, Stephanie, John, Steve, Fernando, Mayank, and Kartik. I want to begin this talk by showing this picture, and this is something you may actually be familiar with. This is a picture of a fictitious woman's face from the site This Person Does Not Exist, and it very clearly shows what the state of the art is for generative AI models. And I'll even bet that if I didn't tell you that an AI model generated this image, you would probably think this was a picture of a real person. But pictures are not the only kinds of artifacts that generative models can produce. And there's been a lot of publicity around large language models like GPT-3 that can produce texts, such as stories and poetry, and even code. And we find code to be a very interesting use case for generative models, because it's actually quite different from other kinds of media, like images. Code requires a certain level of quality to be useful. For example, unlike images, even tiny imperfections in code, such as syntax or logical errors, can render it inoperable. So it seems clear that code is a somewhat different kind of use case for generative models. Let me show you one example of the state-of-the-art for generative code models. This is the transcoder model, which was published last year at NeurIPS. And this model performs a task called neural machine translation. Essentially, what this model does is it builds a representation of code across three languages, Java, C++, and Python, in an unsupervised manner. And then it can translate code from one language to another using its transformer architecture. But even though this model is pretty amazing and pushes a lot of technical boundaries, we can see that its output is not quite perfect. At best, the code it produces passes a set of unit tests about 3/4 of the time, which means that a lot of the time, the code it produces actually has imperfections or flaws. Now, this isn't meant to be a criticism of the model, but rather an observation that because of the way these generative models work, that they're probabilistic in nature, we may not be able to reasonably expect that they'll produce 100% flawless output 100% of the time. So this brings us to our primary research question. Given that generative code models are likely to produce flawed output, would software engineers still want to work with them? Would they find this flawed output useful and be willing to work with it? Or would they feel that it would get in their way and they would rather just write the code themselves? And related to this, we ask another question about how we can make generative code models more useful to software engineers so they can work productively with them. The way we approached addressing these questions was by developing a series of design scenarios in which we explored different ideas for how to support software engineers performing a code translation task. We came up with these scenarios based on our experience working with the transcoder model and our ability to extract useful information from it to show to users. This is an interactive design mockup we created showing the hello world of code translation user experiences. We have some Java code on the left-hand side and a button at the top that says Translate. And when you click the button, the Python code shows up on the right. But even though it's simple, this is a real example. The Python output was actually produced by transcoder, although we pre-computed it to hide the model's latency. Our first refinement to this interface is to introduce highlighting. Here we can see that some of the tokens in the output code are highlighted red. These tokens were the ones that transcoder had low confidence in, and hovering the mouse over one of them shows what the model's confidence actually was. Our next refinement is the alternates interface, where we examine additional ways that the model considered translating the code to Python and show them to the user. In this screenshot, when we click on nums, we see this pop-up dialog showing the alternate translations, and clicking on an alternate would update the underlying code. So now that we created these three design scenarios, we wanted to get feedback on them from software engineers and really use them to have a conversation about generative code models and the fact that they may produce imperfect code. We recruited 11 software engineers from our company, 3 women and 8 men, and we led them through a structured conversation in which they interacted with the design prototypes, and we asked them questions about what they liked, what they didn't like, and what could be improved. We also asked some specific questions to each prototype, such as whether they felt it was important to understand how the model produced the translation, and whether they understood why the tokens were highlighted and how the alternates were produced. These interviews produced a wealth of data which we used to perform a thematic analysis. and for the rest of this talk, I'll focus on a few of the main themes that emerged. So our first theme is about how software engineers might work with a code translation model, and specifically about whether they would accept the code produced by it. And our main finding here is that software engineers were interested in using such a model. In fact, even though many participants said they would be curious or interested in knowing how the model worked, this wasn't really a showstopper for their desire to use it. For example, P6 very explicitly said that he didn't really care how the model works in order to be happy with the code it produced. However, many people weren't quite willing to blindly trust the code produced by the model, which was summed up nicely by P0. He said he would treat the code produced by the model in the same way he would treat the code written by a junior developer, by rigorously testing it before putting it into any system he was building. And this idea of not needing to understand how the model works in order to accept its outputs was quite intriguing to us, because it seems to run counter to a lot of the thinking around transparency in AI systems. However, we did see benefits to having an understanding of how the model works, which brings us to our next theme. This theme specifically looks at the value provided by the two interaction features in our design prototypes, the confidence highlights and alternate translations. And overall, both features were helpful. For the confidence highlights, we weren't quite sure whether people would find this interesting, because it didn't seem actionable in the same way that the alternate translations were. But this feature actually had a lot of value for people because it gave them an indication of where the model might need some help. For example, P6 described how the highlights were useful for steering his attention toward places in the code where the translator did a bad job so he could go back and fix it up. And this idea was echoed by other participants who said that highlights could really be thought of as a checklist to keep track of code that needed to be reviewed, which would be especially helpful for large code bases. But the highlights also caused some confusion. In some cases, there was a token highlighted that the person knew was actually correct. And people who understood that the model was probabilistic in nature were less confused by this because they understood that the confidence was really just a probability. The alternate translations did help people understand that the model was probabilistic because it explicitly showed them what the alternates were that had been considered. Also, the alternates even helped some participants find bugs in the translated code because reviewing the alternates forced them to reason about the underlying code. So this quote from P1 describes how he found a bug by reviewing the alternate translations. And of course, many participants felt that when they went through the code and fixed it up by choosing alternate translations, their feedback should be used to improve the training of the underlying model. The last theme I'll talk about is about the utility of imperfect AI. And remember, at the top of this talk, this was one of the main driving questions of our research. Before doing the study, if you had asked us how people would feel, we really weren't sure if they would be accepting of a generative model that produced imperfect code. But overwhelmingly, many participants expressed a strong desire for help in any way they could get it. P2 described how a code translation model would reduce how much code he needed to retype when doing a translation task, and even if that code had small mistakes, he felt it would be easier to fix those than to do everything from scratch. P6 gave a more nuanced answer, that there's a certain level of quality that needs to be attained in order for the model to be useful. But again, any head start provided by the model would be appreciated. Of course, this begs the question of just how good the model's output needs to be in order for it to be useful, and this is something we're actively working on right now. So to wrap up this talk, I'd like to leave you with these three takeaways. 1, generative code models do have value even if they're not capable of producing 100% correct code 100% of the time. 2, it may not be as important for users to understand how these models work in order to do productive things with them. But when they do have a better understanding, they may have better outcomes, such as not being so confused by the model's confidences. And 3, the two interaction features we looked at were helpful for a variety of reasons. But really, we encourage the community to think of additional ways to extract useful information from generative models to make working with them more interactive than just pushing a button and getting results. So that's our paper, and thank you so much for listening.